So we're going to be graphing sine and cosine today. So if I start with the sine of some angle theta, when the angle is 0, the sine value is 0. And if you remember your unit circle, the y value at angle 0 is 0. So the sine at 0 is 0. When you move around your circle to pi over 2, the y value becomes 1. So I'm going to go up to 1 and put a dot. And when you keep going around to pi, you're back down to 0 because the y value goes back down to 0. When you keep going around your circle to 3 pi over 2, then you get down to negative 1. And as you continue around to complete the circle, you get to 2 pi, you get back to 0. So remember these, the angles, the pi over 2, pi, 3 pi over 2, and 2 pi, those are same as 90, 180, 270, and 360. So the radian values are written here, but they're the same. I could do the same thing with the angle degree values. So the sine function is a wave, and it curves around and will then continue. I could repeat that circle, and I could just continue it forever and ever. I could go negatives, and I could continue it that way forever and ever. But this is it's cyclical. There's a few characteristics that I'm going to point out later, but that's what the sine graph looks like. The cosine graph looks very much the same. It's just shifted a little bit. So if you remember, the cosine is always the x values of the angles. So if we start at angle 0, the x value at 0 is 1. So the cosine starts up at 1, whereas the sine started down at 0. And then as you go around your circle, the cosine goes to 0 as the angle goes up to pi over 2, which remember is 90. And then if you continue around to angle pi, okay, then the x value becomes negative 1. This is straight to the left. And as you continue around, the angle, or the x value goes to 0 again. And then at 2 pi, the x value becomes positive 1 again. So the cosine function is also a sine. It's the same wave. It's just a different section of it. The cosine would curve back down to the left and curve back down to the right. So both of these graphs that I drew shows you one period. So one period of the graph is where it starts to repeat itself. I'm just going up to the right at both of those green marks on the sine graph there. So that would be one period. If I continued this sine graph, it would go back up to there at the next quarter mark. So there would be another period from the peak to the peak. So every common point is one period. So in the cosine, that's what you see. You see a peak to a peak. So that's one period. Okay, so the distance that it takes to repeat itself is the period. So just whenever it starts over. There's another thing, it's what we call the amplitude. So the amplitude is the difference. Amplitude is the difference between the middle of the function and the highest or the lowest, the peaks or the valleys. So the middle of the function is right there. The amplitude for both the standard cosine and the standard sine is just 1, because it goes up to 1 and then it goes down to negative 1. So there would be the amplitude going the other way. Same with the sine. You've got an amplitude at each peak and at each valley. So it's just the distance between the middle of the function and the peak or the valley. So that's the amplitude. We're going to go give you some formulas down here. The standard form for the sine and cosine graphs look like this. So we have some number a times the sine of b times the angle theta plus some number c. So that's the standard form for the sine. The standard form for the cosine looks identical. It just says cosine instead of sine. Okay, so the amplitude you can find from the function is just simply a. And the period is 2 pi divided by b. And then the vertical shift, that's the c number. So that's how much is added or subtracted, could go up or down, to the function. So if it's positive, it goes up. If it's negative, it goes down. The b on the period is the absolute value. So you just take the positive value of b when you're looking for the period. Absolute value. Then the last one, the midline, that's just a line that goes through the middle of the function. And you just add the maximum and the minimum points and simply divide it by 2. So it's just the average of the two values. If you have the c value, the vertical shift, then that is the midline. It'd be y equals c would get you the midline, or you can use a graph and pull out the maximum and minimum values to find the midline that way as well.